Hey, I'm Yash, and I will be presenting Aletheia for Chainlink Convergence Hackathon. We have designed a cross-chain privacy protocol that bridges the gap between public ledger integrity and private enterprise needs. Using a hybrid architecture of zero-knowledge proofs and Chainlink confidential compute, we enabled secure, compliant, and completely private payroll that works across any blockchain. To achieve this, we have built Aletheia on top of the industry's most secured decentralized infrastructure, that's Chainlink. We use Chainlink CCIP to move value seamlessly across different blockchains, ensuring that liquidity is never fragmented. But the real magic happens with Chainlink custom runtime environments, or CRE. This allows us to move heavy privacy and compliance logic off-chain into secure, decentralized oracles. By using CRE, we can use zero-knowledge provers and TEE-based compliance checks that are too complex for a standard smart contract, while maintaining the same level of cryptographic security. So let me just show you a demo. A user simply connects their wallet. After that, they can choose their chain on which they want to deposit their funds on. For this demo, I'm using Optimism Sepolia. Now, when we move forward to our treasury, we can choose the target chain on which we want our funds to be released on. To tackle the issue of linkability between deposit and retrieval, we can use the standard denomination. The UI automatically divides that for us, or we can also use our custom denominations. This gives us flexibility. For the demo, I am just using a single dollar of USDC. I will just approve my tokens. So this deposit causes the compliance cashier to mint a check for us, and we can also see the check minted in our UI dashboard. UI automatically creates a magic link for us. We can use this link in the claim terminal to further do proving and redeeming of the funds. In the claim terminal, a depositor can easily prove their check, and for that they have to paste their magic link. So this takes us to our compliance gate. So this is the on-chain compliance check that need to be verified first before proof can be generated. This is where our first Chainlink CRE service will come into play. The deposit will trigger a Chainlink runtime environment workflow called the compliance oracle. This oracle securely performs off-chain KYC checks inside a secure enclave without ever leaking the employee's data on-chain. Now in the claim terminal, we can see the compliance gate check has passed and user is prompted to add the recipient address. After that, they can provide their signature to prove the ownership of their check. In our current approach, the proving is delegated to our proving service that utilize ultra-honk proving scheme and generates the proof for our Noah circuits. Witnesses of the proof are encrypted and they are only decrypted within the TE environment of our proving service. Our proving service will trigger our second CRE workflow, the proof oracle. It compresses the massive proof into a tiny 32-byte fingerprint and registers only that fingerprint onto the destination chain, which is base Sepolia in our case. But how does the target chain knows the deposit actually happened? Our truth oracle in the background, this is a Chainlink CRE service. It continuously fetches block headers from the source chain deposit and write their state routes to the target chain. This creates a secure, mathematically verifiable historical record, guaranteeing the target network always has the truth about the cross-chain deposit, and it also acts as an anchor for the zero-knowledge verification. Finally, the employee wants to claim their salary on base Sepolia, so they will just paste their magic link and they can just claim that through our claim terminal. This claim process will again trigger our TE environment. Our TE environment will verify the proof that was already present, and it actually sends a HTTP trigger to the verify oracle that will do the final settlement on the target blockchain. As we can see, our CRE report actually triggered a settlement. It sent our request to the compliance cashier, which in turn transferred the funds from vault to the recipient. In our case, which is 1 USDC. Before the employee can withdraw, the target chain needs to have sufficient liquidity. This is where our rebalance oracle comes in. This workflow monitors vault balances across networks in the background and seamlessly moves USDC via CCIP where the funds are low, ensuring withdrawals never stops. Each vault is assigned a threshold value in the config, which means they must maintain that value, and if not, they can be rebalanced from other vaults. This ensures the liquidity is always present on all the chains and on all the vaults. As we can see, rebalance was initiated between Sepolia and Arbitrum Vault, so that can be monitored through a Chainlink CCIP transaction explorer. As you can see, the transaction passed and the vaults are rebalanced cross-chain. Right now, Aletheia uses a simulated TEE setup for our computation-heavy workflows, specifically generating and verifying the zero-knowledge proof. However, our architecture is built strictly around the paradigms of the upcoming Chainlink confidential compute. Once CCC goes live on testnet and mainnet, we are fully prepared to migrate our off-chain proof oracle and verify oracle logic directly into the Chainlink verifiable TEE enclaves. And we are not stopping at payroll. Our roadmap expands this privacy protocol into private invoice factoring, multi-token supports, and fast recursive proof, so that we can eventually run the entire verification layer through Chainlink confidential compute. So this has been Yash presenting Aletheia for Chainlink Convergence Hackathon 2026. Thank you.